All right, question number 11. We want to consider the behaviors of the sine of 1 over x near 0, and then we want to graph sine 1 over x. We see it shown to the right, and we're going to answer this part A, B, and C. So first we want to create a table of values, and so you can kind of see the table has given us sine 1 over x, and it gives us an x value. So I'm going to kind of show you part 1, and then we'll plug in those values. We can do it by hand if they're on the unit circle, or we'll use a calculator. So first, if I do sine of 1 over x, and then I plug in 2 divided by pi, what happens is we multiply by the reciprocal, and so this is just equal to sine of pi divided by 2. Now pi over 2 is on the unit circle, so we can find that exact value. And then the same thing will happen each time I plug in a different value. So the next one is sine, and then we have 2 over 3 pi. That will give us sine of 3 pi over 2. And then we plug in sine 1 divided by 2 over 5 pi. And that gives us sine 5 pi over 2. And if we continue, we'll get sine of 7 pi over 2. And then sine of 9 pi over 2, and then finally sine of 11 pi over 2. Okay, so on a unit circle, we have pi over 2, and then we have 3 pi over 2, and then the ordered pair up here is the x value is 0, y is 1, and down here x is 0 and y is negative 1. And so each time we go around the circle, we just add another pi. So if I added pi here, then the next one will give me the 5 pi over 2. So it's basically like I'm going in a circle, and each time I go in a circle, I'm hitting the next number. Okay. So this value, y value, sine is the y value, gives us 1. This value gives us negative 1, and then the next unit would land me right back here, so that's the 5 pi over 2, will give me 1 again. 7 pi over 2 would end up here, giving me negative 1. And then of course you can test this if I show you just a little bit of the work. If I do pi divided by 2 plus pi, it's just going around the circle. In order to add these, I got to get a common denominator, so this is over 1. And so I would have to multiply top and bottom by 2. And then, so this is the first one. It's going to give us here. Every time we're going like a half a circle. So when I add this, I'll get pi over 2 plus 2 pi over 2. Same denominator now. That's going to give us 3 pi over 2. And if I do that same thing again, if I take 3 pi over 2 and I add pi, I would multiply top and bottom by again. So basically saying 2 pi over 2, and then that will give me 5 pi over 2. And so this is just showing you we're just going a half circle every time to get to the next unit. And so that's why these numbers are just oscillating. You can kind of see how this graph is going up and down and just oscillating between negative 1 and positive 1. And each time it's hitting one of those points. You can kind of see parts of the graph here. Okay. So 1 and then negative 1. So we start out with 1, negative 1, 1, negative 1, 1, negative 1. And then it says describe the pattern. So the values alternate between 1 and -1. It's consistent, or it approaches something. So right now they're alternating between 1 and -1, and as we get closer and closer to 0, it just keeps doing that more and more, faster and faster. So now we want to, it says, why does a graphing utility have difficulty plotting the graph of sine of 1 over x near 0? That's going to be because as it gets closer to 0, it just looks like it's a straight line, or you can't really tell what's going on because there's infinite points. So it says the function is not defined near 0. It says the alternations between -1 happening infinitely many times over the interval 0 to h, no matter how small h becomes. That looks appropriate, and it says the function tends to infinity near 0. Nope, and you kind of see it just looks like a black blur. And then C says, what can you conclude about the limit of sine of 1 over x as x approaches 0? We would say the limit does not exist because it's not going to one point or the other, it just goes back and forth between 1 and -1.